this week was very interesting. This week we talked about computational thinking, and we watched a video on Jeanette Wing, and she broke it down to tell us that computational thinking is like cooking. You put in each ingredient one at a time. Sometimes you have to have certain steps in cooking. You obviously have to do it whenever you're making a casserole or something, because you can't just put a dish in a casserole and expect anything to come out, or a casserole dish. Um, so you have to know what the end product is going to be, and you have to break it down into little pieces. Computational thinking also has to do with organization. You have to organize these bits and pieces and put them where they belong. Otherwise, you are not able to come up with the what end product you want. Something was mentioned in the discussions about how things are skewed in data sometimes, and that is true that it is done that way. I actually know that, especially data analysts, they will skew things to come up with a solution to the problem. They'll go over what they have skewed, and then the employees go back and they try to accomplish that particular goal. And it happens with manufacturers, and it happens with people who are accountant, not really accounting, but they do it in accounting, because they tell you what price, what money that they want coming in, and when money is the end goal, someone else has to figure out how they're going to earn those funds. Wolfram language was also brought up, and that is a programming language. It seems to be an easy one. Some of the other people that we collaborated with this week were talking about having to use Wolfram language, and they were able to understand it. I personally have used Java in the past, and I worked with DOS systems in the computer. We knew what we had to do as an assignment, and you had to, actually, line by line, you had to do it exactly the way just one way to do it. If you didn't put a dot in the right place, or if you didn't do one word correctly, it wouldn't come out right. And it seems like everybody has said again that Wolfram is a lot easier. Java is not easy because of that. You're forced to put in exactly what they want. Also, we had an assignment called Google Forms, where we created a survey. We could do it for math, science, history, or English literature. I found that to be particularly interesting as well, because we had to know what we wanted the end survey to be. I chose to do one on the Army and see how many people would know about the Army. I think that fell into social studies pretty well. And then we had to do a graph or timeline of the American Revolutionary War, and I actually learned a lot from that. I also learned a lot from the survey, creating the survey. I had never used forms before. I'd never really done a timeline on a computer before. Both were interesting. I chose the first option that Dr. Plants gave us, and the timeline was maybe over thorough. But I found it to be pretty interesting, and I tried my best to put it in my own words. I did not, I wasn't very good in history, so I wasn't I wasn't very good at making this, I don't imagine. And then we were talking about weaving computational thinking into K through 12, and it seems like we tend to do more computational thinking as we or students do more computational thinking in the older school grades, because they're more into projects as they get older. Sure, I guess they do some in kindergarten through 5th or 6th grade, but I'm not 100% positive. Once you get to that 7th grade level, though, you are starting to do projects. You could do plants, and you have to know how to, what goes in first, what goes in second, what goes in third, and what your end result needs to be.